Okay, so just like promised, one of the videos about the functionality of the new Zabbix release 4.2. If this is something new for you, just not that long time ago, Zabbix 4.2 was released with huge interesting functionality. If you don't know anything about it, click on our YouTube channel and you will see a quick video overview of the features, or you could go to the zabbix.com and search for the next webinars where we will be talking about the functionality of 4.2, and also you could find any additional information in the documentation or in the zabbix.com. But for today, we're gonna talk about Prometheus. So what I have on my screen is nothing new comparing to other videos. I have a CLI, SSH connection to my virtual machine, which just like always is CentOS 7.5 or .6, it doesn't really matter. Instead of standalone installation of the Zabbix from the packages or from the sources, I have Zabbix running from the Docker containers. If you want to know about the Zabbix Docker containers, you can also check it out in one of the previous videos in our YouTube channel and the Zabbix series playlist. The version of the Zabbix, of course, will be 4.2 because we will be talking about a new functionality. What else? I have a couple of the web pages open. First of all, 2 pages to official Zabbix documentation. One of them will be about a simple Prometheus checks, and the second one will be about low-level discovery based on the Prometheus information with a custom low-level discovery macroses, which also is a new functionality in the 4.2. What else do I have? I have, just for the note for you, the GitHub page of Node Exporter, which is the data source for our Prometheus checks. Like, it is not required for Zabbix functionality to install a Prometheus server. If you have it, it's okay, but we actually will be gathering all the information from the Node Exporter, which is working just like something like a monitoring agent. And we won't be covering configuration steps, how to get it up and running on your systems. Just quickly how you can do that, you can just Google how to install Prometheus or Prometheus Node Exporter on CentOS or Debian or some other distributed system. Or you could just run it from the Docker container, which is also supported. Here you will find information about the collectors, like what information about what features from the system do you want to monitor. Might be like the disk stats, the CPU, hardware monitor, and all of the other information. But well, probably if you already have a Prometheus up and running in your company or your environment, this will be not needed for you. So you'll have to proceed just with a Zabbix configuration. Then I have a Zabbix Frontend with a version 4.2.0, so the latest release of the Zabbix currently. And actually I have already created everything, configured everything that I want to talk about today. Just to save some time, because we don't want to make videos for 1+ hours. And don't worry, we'll go through all of the configuration about hosts, about items, low-level discoveries, all the pre-processing steps, and try to understand how it works. But we need to start with the actual CLI. So the CentOS 7, and again, let's verify that yes, everything is running from the containers. What I will be using, so systemctl status node exporter, this is like Prometheus agent, so we will be using it to gather all the data and collect it inside a Zabbix. So we can see that service is up and running, and you have to decide how you will install it. Where can we get all the output of the metrics that Node Exporter currently collects? There is no complex like configuration web page, some configuration files where you can find the metrics or something like that. It's pretty simple. What we need to do, we can just run the curl request to a local host, and the port is by default 9100 / and metrics. And in the response, we will see the Prometheus output, which basically contains of it would be like, well, the line starting with a hash is just the help information, like description about a metric. Then we have, let's take other example like this, node XFS, location, other stuff. This part till the brackets is a metric name. Then in the curly brackets, the device, it is a label name. And in the quotes, it is a label value. So we'll be using that a little bit later. And the digit behind it, it's the actual value of this counter of this metric. And using the new functionality of the Zabbix 4.2, we will be gathering and processing all of this output to extract what is needed for us. And it is also possible, and we will do that, creating the low-level discovery. Like, instead of picking one single metric with a static metric name, a label name, and monitoring it, we will be doing discovery. Because, like in my case, I've initially created a monitoring for the network interfaces, and you see, like, it mostly contains information. There are a lot of network interfaces currently because I have a Docker up and running, and if I would do a little reconfiguration, all of those interface names would change, and the static items would also not work immediately. But if I am using low-level discovery, if the device, the interface name will change, it will be discovered again. New items will be created based on the item prototypes, and the monitoring will continue without any interference. So let's get started with the front end. What do I have here? I have a Prometheus host, which is a local host, and this part actually doesn't matter because the monitoring itself is absolutely not related to Zabbix agent or some other Zabbix components like Java Gateway or the proxy. In my case, the server will be doing the monitoring tasks. And I've also added tags to this host like the environment development and environment Prometheus. Just for the example, because also the tags on the hosts is a new thing in the 4.2. So, in terms of the host configuration, absolutely nothing new. It's just a regular host in the Zabbix with a host group on one interface because it is mandatory, and a host name Prometheus. Then the items. You can see that I do have one low-level discovery rule. That's why I have 25 items, and see, these ones are created from the low-level discovery. But before LLD, let's start with simple items. Simple items, and to do any Prometheus monitoring, we will need to create HTTP agent item. And in my case, this is this one, Prometheus node exporter. The master is the key, and what do we have here? Master with the URL, which is the same URL I've just executed here. Localhost, just I am doing not localhost but actual IP address, which is 192.168.56.101. There we go, same result. So this is where I get the URL. Then go back to the front end and /metrics, just like we did in the CLI. And that's basically it. There's not many things you need to do at this point. The only thing I decreased the timeout for 3 seconds because, well, for the testing purposes, I don't want to wait like 5 minutes to get a fresh data. And another thing that I did is type of information. Do not expect that the output of the master item that is gathering all the output of the metrics page will be the integer. So we need to change it to the text. Yeah, sorry, I was talking about the timeout, but Well, basically I was meaning the update interval, 5 seconds. Another thing that I would normally do, but for this case I have the history storage period 1 day, but actually I would specify this to 0. And if this is specified to 0, it means that there is no information written to the database of the Zabbix. You can see from the CLI output how many lines, like, let's check, 1,151 lines from the output. Each check would be written to the Zabbix database, which is absolutely not reasonable. So by specifying the history storage period to 0, all of these gathered metrics, all of this output would be basically thrown in the trash after the pre-processing, after the processing of the data and processing of the dependent items. So that's it. That's all I would do for the master item. And update, save it, and we can check in the latest data what's the actual output of this item. So when we open the monitoring latest data, we can find our Prometheus node exporter, the master item, and we can see the output that our master item has gathered. Like if you click on the history, all you can see here is basically the same output that we were seeing previously in the CLI from the curl output, this one. So this is gathering all the information, and if we would specify the history storage period to 0, none of this would be saved to the database, because it really doesn't make to save all of this to the database. It just takes a lot of disk space, and also worsen the performance of the Zabbix. So we got done here. Let's go back to the configuration hosts and to our items and check how I've configured the simple items without low-level discovery, just a regular simple item that does Prometheus pre-processing and extracts the values. Like when I am creating an item, it is basically mandatory to specify the type of this item will be dependent. And the master item for all of our Prometheus monitoring items will be the Prometheus node exporter, the one that I showed you like 2 seconds ago, the one that gathers all the information from the CLI, from our localhost metrics page. Then, so it is a dependent. We do expect that it will be a numeric unsigned. This is determined based on our CLI output. Like I don't remember obviously in which line was the metric, but you see like value 0 or 200, 224584. So this is an integer. So you need to check what will be the type of information. Since we know that this will be numeric unsigned, you can specify the history storage period, trend storage period. Everything of this is nothing new. So it's absolutely the same as you used to when you're configuring items. The new thing in terms of Prometheus monitoring is pre-processing tab. So there is a new pre-processing option called Prometheus pattern. And here we have 2 options we can specify. First of all, node network transmit packets total. So this part till the curly bracket would be the metric name. And the last part is a label device with a label value, which is a network interface. And if I would like copy paste this and let me try to do like this. Nope. There we go. So this one, right? S3, let me check again. S8, okay. So it's this one. And there we go. So based on this pre-processing, I am specifying, because I have a full pattern there, I am specifying all the metric name with the label value, which is a network interface. And in the monitoring latest data, I am getting the actual value, which is this one. the actual value which is extracted from the master item. The next one, simple regular item that I have on the configuration hosts or Prometheus host items is basically the same also, but in the pre-processing tab I have the same key. It's still a dependent item. It's still dependent on the master item that is gathering all the output from the Prometheus, but in the pre-processing I still have a pre-processing option, Prometheus pattern. The parameter is same metric name, transmit packets total. I am again specifying device equals and a label value, but here in the label name I am specifying which what do I want to display. So the label name called device, this one. And in the output of the item, I will get the value of the label name. And the value of the label name is the interface name. Not the packets, not the bytes, but the interface name. So we can check in a monitoring latest data. There we go, NPS 08. This is the actual value that we are getting. And let me actually try to draw it to you on the screen. So what happens? We have our, how we write it, like node exporter, which is monitored by the Zabbix server. It gets like huge output of the information, the one that you saw in the CLI, like many lines. This is for the master item. And then we have dependent item 1, dependent item 2, dependent item 3 that, based on the pre-processing step for Prometheus monitoring, extracts the specified like line or one single value. And when these values are extracted, all of this information, all those 1,000 lines of the values are simply thrown away. That way we don't spend the storage space and we don't put a big load on the Zabbix to write all that information to our database. So let's close this one. And I hope it did make some sense, but let's continue to the next thing. And the last thing for this video is again about the Prometheus, but about a low-level discovery. So we need to go to the configuration hosts, and I have here Prometheus low-level discovery rule, which is not a built-in, not a built-in key like you've used to file system discovery or network interface discovery. It is basically a custom rule, which is again a dependent item, and it works just like those items I showed you seconds ago. So it is dependent on our master item, the one that is returning all the output. Keep lost resources period 0, that's nothing new, just regular stuff for low-level discovery. Then pre-processing. And in the pre-processing, there is also a new pre-processing step called Prometheus to JSON. So this step will get all of this output, this one, not this one, but without the grep, this one, and convert it to the JSON. But I am additionally specifying that I don't want to capture absolutely all output, not those 1,000 lines. I want to capture only, let me zoom in a bit, the lines where the metric name is node network transmit bytes total, the label name is device, and label value is anything. This is regular expression. And you can see here in the documentation, I'll definitely post the links to the docs in the description of the video. So how we can search by the metric name that we did in the first items I showed you, then select by the metric name, or select by metric name matching a regular expression. So equals like, and then a regular expression. The metric name like something. Select by the label name, like also in the item I showed you previously, or label name and the regular expression. So this is the one that I am doing right now. In this example, I have a metric, a label name, and a regular expression equals, like, regular expression, anything. And this rule, Prometheus to the JSON, will capture all the lines that will match this regular expression and convert it to the JSON format. Now let's look how the JSON format actually looks like. This is an example. Zabbix will convert to the JSON format with the following format of the JSON. Like, there will be metric name. We talked about what is a metric name. Like, this part is a metric name. Then there will be additional object, the metric value, help information, so the line marked with a hash sign if present, because not all metrics got them. Then the type, labels, and the raw line, like the full line, the same that you see in the CLI. And there's also the examples like the name of the metric, help information, type, labels, what kind of labels do we have, the volume label name with the value C, the value itself, and the line raw of the metric with escaping the backslashes. So how do we configure in the Zabbix? How do we specify what kind of low-level discovery macros we will be using, and the most important, how to feed those LLD macros with the actual values? For that, we will be again using, let me actually show you output of this grep. Yeah, it's the same. So basically, we will be getting this output in the JSON. This is what we can operate with. And now we need to create our custom LLD macros and feed them with the values. To do that, we need to open a new tab, LLD macros, which is also a new thing in the 4.2. Here I am specifying that I want to have LLD macro, syntax is the same, curly brackets, hash sign, uppercase, device. I can choose the name as I want. It's not mandatory to use the name device. You can type whatever you want. And then remember Zabbix 3.4, the pre-processing was just introduced, and there was one of the pre-processing options, the JSON path, where you can specify that JSON path to the created JSON. And I am going to the labels and device. And all of the values of this JSON path will be fed to device low-level discovery macro. Help macro will be also using that. And again, a JSON path to our converted JSON output. The metric is the name. These are the macros that we now can use in our item prototypes. So we have a low-level discovery rule that filters the output from our Prometheus output, and based on the regular expression and also the pre-processing rule convert to JSON converts it to the JSON. Then we have specified our 3 LLD macros with a JSON path, how to extract them, and we can create item prototypes, and I've already did. So create a new one. Again, nothing new, it's still a dependent item. Not a Zabbix agent, not ODBC, not HTTP. It is dependent item that is based on our one single master item that is responsible to collect all of the information from my localhost node. The key for the dependent items, there's no specific key. I am just using a total because the metric name is total transmit packets, and in the parameter brackets here, I am using LLD macro device first of all because we need to be sure that item key will be unique. If I will not use any LLD macros here, our LLD rule will simply become not supported, cannot create item, the key something already exists. Then the master item, we need to specify it. Type of information, remember we need to check here in the CLI, what do we expect? These are actually scientific values, so you need to specify a numeric float. We're talking about a byte, so BPS, and show value as is, nothing new. Help. Remember, in LLD, custom macro tab, I will even open it again, Prometheus LLD, LLD macro, help, is from the output help. So, let's open here. Like all of the discovered lines that will contain a JSON object with a help, like free space in bytes, the description of this metric, will be written to the new created item description, which means that anyone that will open that item's configuration will see the actual description of this metric, what it actually is. Second thing, the pre-processing tab. That's again is the most important thing. We still need to specify Prometheus pattern because, okay, we are creating an item, and what I want is I want to have a separate item for each of these metrics, for each of these lines, and I want my low-level discovery to get this output, form it as a JSON, and using item prototype create, I don't know, 20-something items that we have here. So we still need to use Prometheus pattern. And the pattern is, remember, we need to specify the metric name. We don't know it. It is based on the low-level discovery rule, and it is extracted from the converted JSON to the low-level discovery hash metric that I've specified in my LLD rule based on the JSON path pre-processing. Then there are curly brackets, the label name device, and device value, we don't know. It is again based on low-level discovery on the pre-processing by the JSON path, and the value is stored in the LLD macro hash device that I've also have specified in my LLD rule. So that's it. And since we're talking about traffic items, the ones that will be collecting the bytes per second, we need to add also the pre-processing rule change per second, which again is absolutely nothing new for the 4.2. That's the whole thing. No need for me to update because I already have created, but let's go to the configuration hosts and check what kind of items I do have in the end. So all of these are created based on my low-level discovery rule, the custom one with a custom low-level discovery macros and Prometheus conversion to the JSON, and then Prometheus pre-processing to extract the actual value. You see that all of them are dependent items, except of these two that are completely static. This one is just a test, and let me actually show you, yeah, why not right now, like the monitoring latest data, Prometheus test. This test item, I've created it to show how looks the JSON when the Zabbix does the filtering on the one that I showed you. Yeah, too complicated. There we go. Then JSON formatter and Google, JSON formatter and validator. Just copy paste the value to make it, let's say, human readable. And you can see the name, node, network, transmit, bytes, total, the value, scientific one, the line row, labels, device, and the interface name. This is how the JSON is formatted after the low-level discovery rule processing. There we go. Then what else we can check in the configuration hosts items? Let's see how those items actually, how those macros actually open it up. Let's pick one. Node, network, transmit, bytes, total on. Remember I had here, let me open this in new tab, the low-level discovery with an item prototype. Metric, LLD macro on, LLD macro device, and in the end we get a metric on and the label name, the label value, device value is the network interface. Then the most important step is the pre-processing tab. So this is the item prototype, and it should look like the metric, then curly brackets, label name, device with the label value from the LLD macros. So when the item created, it revealed like this. Prometheus pattern, the node network transmit bytes. This one comes from LLD. And the label name, device, and the label value again comes from the LLD. Based on this, we basically automatically create the same static items that I showed you initially, like these two. So, that's about it. I'm not sure. I guess this sounded like a bit of crazy, and maybe I was explaining it a bit too complicated to understand. If you have any experience with Prometheus, I believe it was nothing complicated and nothing new for you. If this is something completely new, I probably would suggest like watching the video, I don't know, maybe even 2 times, and the most important, try to create the same items, the same low-level discovery rules, just like I have here on your test system. And to do that, I really suggest to check once again our official documentation about low-level discovery and about the simple checks of the Prometheus, because there are also examples, the explanation of parameters like in the pre-processing, the pattern, the output, and it's optional, it's not even mandatory. The syntax and differences for the PromQL and the Zabbix Prometheus pre-processing syntax. For the LLD, like what kind of output will be the JSON, and you can see the example of it. Some macros, how to define them. Basically, all of the stuff that I showed you in this video. And in the end, you should be able to get your result. I definitely do suggest to use low-level discovery. Yes, it will be like way more complicated to configure rather than a normal item, but it will make more sense, because if something will change on the device, the LLD rule will discover the changes. May something is gone or some new interface is added. The changes will be discovered based on the item prototypes, the new items, maybe also the triggers will be created, and you will have a full monitoring of your environment. So that's about it that I wanted to tell you about a Prometheus. I'm again not sure how much minutes we talked. As usually, around 2 times more than I've expected, but I really hope that it makes some sense, and hopefully after watching this video you will be able to configure this on your own. If not, if something is still unclear and you cannot find the answers in the documentation or in the other sources, don't hesitate, just like usual, ask the questions in the comments. I will, and I am reading them, well, always, and I will try to answer your questions and help if the questions will make sense. Like, don't expect that I will give you some awesome advice in terms of Prometheus node exporter configuration. That's more like Prometheus documentation stuff, but if something is not working in the Zabbix in the front-end configuration for LLD or something else, of course, ask and you will get advice from us. So, once again, that's about it, and have a good day, guys, and see you in the next episodes. So, goodbye.